Alrighty. Showtime. What's the word? How the revision coming along? So we started in like 5 minutes. Like we just wait for everybody to touch down. The them things start. I was by the school the other day. What school is this there? Who know what school is this? What school is this? I'm late. I come in 7 o'clock. My time was still saying 7 o'clock when I come. So try that. Javish, what's he seen? One of the OGs from back in the days. So when you go do all the lad maths live, you could do something just now. We could do something just now. And not a school in Trinidad, correct. That is not a school in Trinidad. It's in Jamaica, correct. It's in Jamaica. That's a Jamaican school, correct. You feel my time slow? No, brother. My time exact. I mean, I didn't start plumb on 7, but it didn't turn from 7. Right now, the AC on my back and it's freezing, my boy. What is this? Ting. I get my keyboard to still work, but one of my screens now working. Every day is a struggle to try and do right in the society. Every day is a struggle to try and do right in society. Oh gosh. Integration, good luck with that. Jamaica in the house. Jamaica, lock in. Jamaica in the house. Somali, yeah. We do have that maths crash course here. We having those so you can WhatsApp the student up, get through. Vectors and matrices coming up. Today is Sunday. So you're singing church today? I don't sing, bro, in church like that. I mean, if you can look up actually, there's some songs on YouTube. Yeah, you can search Kerwin Springer songs, and you can see we had some shots from back in the days when I just started the YouTube. But maybe I could do something, jump in on the Kendrick, Jake, flow. We started in 2 minutes. We just waiting for everybody to hop in. But yeah, last night I was practicing the keyboard. I had to play the keyboard in church. Yeah, some bad songs, some very bad songs. Some very bad songs. Make it your mission to go and check them songs afterwards. If they give me enough encouragement, I might, excuse me, run out with something this year. I'll press like on this stream if you reach. I forget to say that yesterday. Yesterday was so much stress. I forget to say my motto. Press like. Oh gosh. So every day you can go work so right. Every day I had to reset you right. Every day. Kerwin Spring original diss track. Right now, CXE done down 3-0. Oh gosh. Are you ready? 1 more minute. 7:05. I just gave them a little time to touch me. Press like in the meanwhile. Big up Shanika. Big up Jelia. I don't know about the Netflix series here. Let's see if I can pull along one ago. Real wildness happening in the paper trees, but anybody here do some paper trees? Paper trees for physics and chemistry supposed to be allowed to go in the exam with notes and things. Some examiners don't know that. So they're stopping the students from going in with the notes. Imagine you show up with your notes ready to do the exam and them stop you from carrying your notes. Yeah, because it's labs now, so they let them do the notes. Well, how the likes looking. So we're getting ready to start here. I really need a mouse. So I need to bring a mouse at home, boy, because I'm struggling right now. So today, I saw accustomed to online classes are looking for the record button. Before you start online class, you have to press record, because if you forget to record, you have to do over that class because people want to see what you recorded and think, and there'll be no vibes. Anyhow, So today we're going to look at construction, basic trigonometry, and transformation, geometry, everything geometry. This is what comes in question 3 in the paper. So this is where our focus will be today. We're going to have some fun with this. Before we start, can you give your rating on construction? Can you give a rating on construction? Why am I thinking looking so fishy? Out of 10, how good are you in construction? Some people really don't like this topic. And what about transformation? Out of 10, how good are you in transformation? Basic trigonometry will include sine, SOHCAHTOA. Let's see if it's just this board or no. If this now, we can be in problems. Everything else could play around, but SOHCAHTOA. No, TOA. Why it's skipping like that one? What is the next topic in basic trigonometry? So we have SOHCAHTOA, which is trigonometric ratios. What's the next basic topic in trigonometry? The next basic topic. Basic trigs now. That's coming in section 1. So SOHCAHTOA is trigonometric ratios. The next basic topic is what? Is we partner from the old school. So I'm saying I'm going to turn you off, wipe you down, and turn you back on. And you had to be yourself there, but you had to conduct yourself properly out here. Yeah, my brother. Right. Work now, bro. Why you skipping at the press hard then? And they're gonna be a little sticky today, but we powering through. They're trying to fight it up. So Pythagoras theorem, PT, Pythagoras theorem, and SOHCAHTOA are the two important topics in basic trigonometry. Pythagoras theorem and SOHCAHTOA. So construction in triangle ABC. That's all. I'm gonna make sure I have nothing running. That's skipping, man. And we always give off that little rocky start, but don't worry, it's always sort back of myself. Like I need to run a demo class before class start. So we have this question here, and they want us to use a rule and a compass only, construct triangle ABC. The line AB has been drawn for you. So I'm going to give you all a quick crash course in construction geometry. I'll load up this thing here. I just find this today. Today I find this. I ain't really use it since then. So all you know to draw a line. All you know to draw a line and measure the line to seven and think everybody know to draw a line, right? So you come here, like if you wanna go from 0 to 7, that UD proper things. But more importantly, how do you bisect a line? You know how to bisect a line? With a compass. Hopefully you do have the compass that look like this. These compasses be real shaky. No, it's stick my computer sticking. That's what's going on. But how? Anyhow. So what you need to do is subtly point. I will turn off this program. Just subtly point there. Open this up a little more than half. Everybody take out your compass and start working. Take out your compass. The chances of you bisecting a line or an angle in CXC in the exam in the next less than 10 days is extremely high. So make sure you know how to do it. And then you want to draw the arc. Like this. A little shaky. They're the first time I'm using this program there. Then you come on this side and start with Mindy. Keeping the same distance. Oh, shucks, I had to start over. I lost the distance. You see what happened there? But you all understand why I had to start over? Because I had to keep it the same distance. So I'm going to unlock this thing. It locked. Hopefully that means that it lock. And I draw in my arc like this. I bring him across on this side, or you should be working together with me. Stick him in there. Come across here, my brother. And what I'm going to do is draw the next arc like this. Bam. So here's my next mission. My next mission is to take the ruler, turn it vertical, and I want to like pass the ruler through this point, these two here. Why isn't it chat if you understand that? Read out that it. Now there's a video I have on YouTube called Construction. It's probably one of the best. It's probably the best thing you could do if you don't understand construction. So now you just bisected the line. You also created a perpendicular bisector. So if you look at, let me change the color. If you look at my boy here, this is actually a perpendicular bisector. It's actually at 90 degrees. I could draw 90 degrees there. Yeah. What else? So you bisect the line. Now, do you know how to bisect an angle? Do you know how to bisect an angle? An angle is when we have two arms meeting each other. So let's say boom, bang. How do we bisect the angle here? How would we bisect the angle? Well, you want to take a compass. Why the compass over there? Trying to get the compass in a decent spot. Come across here. Excuse me, this is the first time I'm using this program. A little clunky with it. Have I eraser? I really want to get rid of that line. But anyhow, small thing. Pretend you ain't seen that little blue line I have in the corner there. So that's an angle, right? Bisecting the angle means splitting it into two equal pieces. I'm going to stick the compass there. You can open it to any length, a reasonable length, right? Let's change the length. Oh, a bit lock. So I'm going to just open it to a reasonable length about here. So, and what I want to do is draw. Maybe I should draw that line blue. Draw an arc like this and make sure it cut through both sides. Boom. Everybody have that on the paper? Everybody have that on the paper? Yeah? Calculate the little lines and mistake I make. Then the next part, the next thing you want to do is come up here, stick in that, and you could switch the length up again if you want, but most of the time I just keep it the same for this. And I'm going to draw an arc here, bang. Then I'm going to bring you over here like this and draw another arc here. So what I would have done is made a point up there. That's my point of interest. So my ruler, when I enter the show again, bring you up, on board viewers causing higher problems. Bring you like this, bring you up a little bit. The struggles. Bring this up. Yeah, and then I want to connect through that with my, let's go purple this time, and I would have bisected the line, the angle. So far we just do a quick review on how to bisect an angle. It's sticking every now and then, rate limiting itself every now and then. Just gonna close some programs. And we learn how to bisect a line, how to bisect an angle, and how to bisect a line. So rate out of 10, how much you understand that? Everybody understands? construct this triangle. So we have a triangle, one side is 8, one side is 5. The line AB has been drawn for you, and they already draw a line for us. So let's go do this triangle. This is a triangle, and we need to draw AC, which is 8, and BC, which is 5, but they draw AB for us. So let's pretend, let me clear this whole thing. Let's pretend this is the line that was drawn for us here. Clear, take off that ruler. Let's pretend this is the line that was drawn for us. That's AB, right? So we're pretending this is the line A, B, and we want to draw AC and BC. But they told us that AC is 8 and BC is 5. AC is 8. So what you're really supposed to do is unleash your ruler on them like this. Line it up on your paper. Take a compass out as well. Over. Take a compass out. Stress with this compass on it. Line it up. Right? And you're trying to open the compass out to 8. Compass, you can make a little 8 for them there, bro. That's how you're supposed to do it, you know. That's what they want to see. So, as I said, I have a YouTube video where I do this way neat and actually use a real compass. And you want to make an arc with this somewhere up there. So this is 8 right now. And you have an arc there. So anywhere along this line, you understand is 8. That's AC. AC is 8. And BC is 5. So if I bring back the ruler in the dance, that making sense for people? If I bring back the ruler and set back my compass on the 0 and bring the compass down to 5 now, boom, lock him in the goodbye ruler. And what do you think I'm going to do? I'm going to come from B now because BC is this 5. And I will make my arc right there. So that means, and they want to see the arcs. They want to see the arcs like that. They're looking for you call them construction lines. And then you know what you're going to happen. You're going to connect. You're going to use your ruler and connect like this point to that point, this point to that point. Now, your final diagram, your final diagram should be drawn with darker pencil, and I show you how to do this in the video that I have, the construction video, than the construction line. So this is how you would look in the end. You would come now and write a little, right up, compass popping out all the time. So you come here and write a little C for them. What else you will do to secure the bag is only 2 marks. A, B, C, use a compass thing, 8 and 5. In technical drawing, when you are given a dimension, you really and truly you had to put it in afterwards, right? So you had to write that this is 8 cm. You use a ruler to do this. This is 8 centimeters. And this over here is 5 centimeters. 5 centimeters. And you would use a ruler to accomplish this, 5 centimeters. What y'all think? Rate out of 10 how much y'all understand this. Everybody understand this inside out. So using a ruler or compass only construct the triangle ABC, the AB has been run for you. And then measure and state the value of angle BAC. Now, this is not exactly what was in the paper, so it would be a different answer. But I want to show you all how to use the protractor. This is a protractor. I'm going to make it a little bigger. So, for using the protractor to measure, the protractor has most people protractor have 2 separate spots. You have the underneath of the protractor. So you have the protractor like this. And then you have a base line here. What's your protractor? You have a base line right there. And then you have this line as the center. Just like how it was in the thing that I'm using. Is it because I'm touching the mouse? Yeah. So it lagging, the live lagging or good. So what I want you all to look at is this green line that I just draw above the blue line and hopefully looking green and blue on your screen. No, the live not lagging. No, it's just earlier. If you're like, ha ha ha, a man tell me, yeah, fix your Wi-Fi. Well, like it's not a you problem. So if you look here, you would see the protractor ends down here, but there's a baseline 0 to 0, 180, 180. And you have two scales going 0, 10, 20, 30, 40, 50, all the way around to 180. And then you have this scale going all the way around to 180. What you need to remember with your protractor is that you need to measure from 0. So what angle they're looking for again, class? They're looking for the angle BAC. BAC, so where's that angle? That angle has to be, you'll understand how angles work. That angle has to be this angle they're looking for right here, right? That's the angle they're looking for. That's the angle in the question. B to A to C. So measuring that angle, I will put the center point of the protractor right there. And what side do I use? Do I use the bottom scale or do I use the top scale? Would I be using the scale on the inside curve or the scale on the outside curve? Remember? That's not I'm conscious. Yeah, remember you had to start from 0. So 0 is on the inside. So this is actually 30. How much? How much it looking like? I'll watch my screen. So some people they say 45, eh? It's not 45, you're counting this way 0, 10, 20, 30. It's actually 35 or so degrees, yeah? What are you looking like? Yeah, it actually looking like plumb 35 degrees to my eye. Plumb 35 degrees. So that angle, if this was the AB, would be 35 degrees. Now it would be different in the past paper because I just make up an AB using my own thing, my own style. So guys, just give me 1 second. I'm gonna have the next question on the screen, and I want you to calculate each. So whilst you're doing that, actually you might see the screen blinking up and all kind of thing, but I am just getting rid of some programs. I don't know what is making my screen pulse like that. What is the answer for each? So the topics that we are doing on install, brother. I don't want you here. What is your name? Thing. Nice. Must be as you pausing on screen. So the topics we are doing is geometry and trigonometry, construction, and transformation. We do a bunch of transformation just now. So I want you all to get the value of each. Can you get the value of each? I still need to just plug this out and plug it back in quickly. You're gonna pop back up just now, don't worry yourself. Right? So can you get the value of each class? I also need to pop back up my display settings. I just switching back some settings here while it's all working order. No frighten, no frighten. I should still be seeing the screen here. H is 11.25, 11.3, 11.25, or 11.3. So what do we use to find H? So I'm going to teach you only two basic things. Once more board working good. Please work good board. Please. So no, it's still doing the shipping straight. It freezing every 2 seconds. When I have enough time, to leave the live and come back. Are you go wait for me? I have enough time to leave the live and come back. I'm going to be back in like 2 minutes. Are you wait for me, right? I just really want to teach you these two basic topic and tricks. Just let me see if I restart would help. Right, I'm back. So here, what am I looking for? Just to bring up my notes. And it working better. It was a good idea to restart. Because that stress me out to just keep coming to. I had to go through that over and over and over. Just bringing up my notes, guys. Give me another second. Wait, are they hearing me? Let me just make sure they hear. Looking stressed? Nah. I good. I rock here. Doing my maths. I'm a little percentages. Joking, and that was a joke earlier. And they say this man is me. Is how he's had energy. He's teaching maths with the percentages. Percentages. Boom bang bang. I'm a little drawing program, but fighting to bring you back up by drawing program, boy. Next thing you was the cause of all my health problems. So let's do the two. So it's really three topics we're focusing on today. We're focusing on geometry, and the three topics is trigs, construction, and what's the next one, boy? Transformation, which we didn't really touch on. So let me knock off the trigs one time. Trigonometry. This basic part of trigonometry, I really want you all to focus on Pythagoras theorem. Pythagoras theorem. And who is the next one I want you all to focus on? Is SOHCAHTOA. SOHCAHTOA. That's the shortcut. We used to remember them. And this is called the trigonometric ratios. Trigonometric ratios. So how well do you know these guys? So let me see what we use them for. Firstly, the first thing you should know, this is basic trigs, not the advanced stuff. So all of these two rules are used for right angle triangles. Right angle triangles. So that's the first thing you should know. Only right angle triangles can be used for these, right? Excuse me. This one is used for finding a missing side. And involved, all right, who involved in blue? You have 3 sides involved. One of them is missing, 2 of them given. You all understand that? We're gonna explain, we're gonna go through it just now, but you understand so far? What I'm writing here is just English. I do no maths yet. Pythagoras theorem is for finding a missing side on a triangle. 3 sides involved in the question, 1 missing, 2 given. You find the missing side using Pythagoras theorem. What is SOHCAHTOA or the trigonometric ratios used for? These are used for finding, I can't write with the highlighter, see. Finding a missing side as well. Really? Oh, angle. Well, yes, look at that. So you can use the trigonometric ratios, the SOHCAHTOA thing, the sine, cosine, and tangent rules, and we look at the ratios just now. We could, a new Drake dropped. All right, your class finished. I'm going to listen. Just kidding. Just kidding. Finding a missing side or angle. And however, the difference is that you'll have 2 sides and an angle involved. It's important when you're thinking about maths and studying maths to kind of compartmentalize everything. All right, in basic tricks, there's these 2 topics, Pythagoras theorem, SOHCAHTOA. This topic is used to find any missing angle, 3 sides involved, missing angle, missing side, but you'll have 2 sides and an angle involved in the question. So which one are you going to do first? Are you going to do number 1 first or number 2 first? Number 1 first or number 2 first? Pick one. Lock in, all you lock in. Jake writing all your maths all you. Like now Jake fighting. I'm going to sound like a picking aside. Number 1 first. They want to do number 1 first. So Pythagoras theorem. Pythagoras theorem. So we have a right angle triangle. We could call this side A, we could call this side B, we could call this side C. And next thing we do is we call this A, we call this B, and we call that C. Look at that. Do you notice that the side is opposite to the vertex? If you didn't know that, you wasn't paying attention in class because that happens all the time. This side is C, but this point here is C. This angle here is angles at C. This side here is A, but opposite. Oh gosh. That is just how we do it in maths. That is just how we do it in maths. So the side that is called C could also be called A to B. Yeah, and all right, but I know what we're here for. We're here to learn Pythagoras theorem. So what does Pythagoras theorem say? It states that C squared is equal to A squared plus B squared. Or in words, the square of the hypotenuse is equal to the sum of the square of the other 2 sides. That's how you say it in words. Pythagoras theorem. The square of the hypotenuse is equal to the sum of the square of the, which make perfect sense. So this means if I have a triangle and I know this side is, you looking like a 10 and you looking like a 6.3. I can now call this triangle PQR, and they can ask me, what is the length of QR? What's the length of QR? QR is the hypotenuse because it's opposite the right angle. That's your C. So what I want you to do is, in this, you could always come back and say, I am the boss here. You can literally say that in the exam. I am the boss here. Give yourself a little crumb. I am the boss here. And I want to call the side C. And I go call the side A, and I go call that B. So I am saying, by Pythagoras theorem, C, which is what you all call in Q to R, by Pythagoras theorem, C squared is actually equal to A squared plus B squared. So C squared is equal to 6.3 squared plus 10 squared. Oh gosh. So C squared is equal, and we're moving it a pace here. You all know how to put on your calculator and look good? Right now I'm running a free version calculator here. Bring him on the screen. Now let's see the calculator yet. Nah, it didn't look like we've seen it. That's not out there. Let me see that calculator. Calculator. So what I want to say is 6.3 squared. I didn't always do it as well. Break it down at the start of these videos, but then I start to move at a speed, right? 10 squared. So you get this. You can press boom. 139.69. I'll understand that 139.69. Is that the final answer? Is that the final answer? No, how that can be the final answer? That's C squared. You're trying to find C, bro. So you put C is equal to the square root of 139.69. Good job. 139.69, square root that. So let's go back into calculator land. There's a fast way to do this. Calculator, where you going? I say my princess gone. Oh, far, far away. All right. So 11.82. Smells like a 11.82. So therefore, come in here, right? Therefore, C is equal to 11.82. Or QR is equal to 11.82 units. They didn't give me any units. Another thing that can happen with Pythagoras theorem is that they can give you the triangle, and then you notice side that missing is not the, somebody say I just come from church. So I think, anyhow. You see how that person distracted. Shadrach locking. Shadrach is the locking boss. You're not supposed to be distracted. Anyhow, so some weird things happening in each chat right now. So how do you find X in a situation like this? We use Pythagoras theorem again. Because remember, basic tricks, right angle triangle, three sides involves. If it's three side involved, you use Pythagoras theorem. If it's two sides and an angle involved, you use the SOHCAHTOA. There's no angle involved here. There's just three sides. So what you want to do is come now and say what? What are you going to say? I am the boss here. I have the pen. I am the boss. So I will call the side C, A, B. And I will say by Pythagoras theorem, C squared is equal to A squared. I don't like to write two equal signs in one line. That don't look good. C squared is equal to A squared plus B squared. And then I'll fill in the blanks. C squared is 13. Feeling mighty fine about that 13 there. Yeah. A is X. So that's C squared, 13 squared. X squared plus B is, no. A is actually 4. Not that it really matters. 4 squared plus X squared. What do you think about my substitution? Fine work, right? So 13 squared is 169 is equal to 4 squared is 16 plus X squared. Bring across the 16. You're catching the flow, you end up with a rearranging kind of vibe. And 169 minus 16. Now, you're not going to get to see this calculator work this time. I want to get the square root of 153, which is approximately, not x squared, x is equal to the square root. Once you have the square root, you get rid of the square, which is approximately equal to 12.37. And I see now they pay the answers. 37 units. Are you lucky or are you talking about who married and thing? 12.37 units. So that's Pythagoras theorem. Well, next up, we're going to learn SOHCAHTOA, which is a little more piece to learn. SOHCAHTOA, I could go a little deep into this, but that would take too long. It might take about a half an hour. So I'm just going to touch the surface, and hopefully you all remember everything from it, right? The S here stands for sine. And what we say in the sine of an angle is always equal to the opposite side divided by the hypotenuse. This is a fraction. Don't think too deep about it. The cosine of an angle is always equal to the adjacent side divided by the hypotenuse. The tan of the angle is always equal to the opposite side over the adjacent side. So we introduce some terms there. Sine, cos, tangent, sine, cosine, tangent. We also introduce up, your ups. This is not the ups that you're talking about. They're not the people who fight in your don't hold 5 years now in secondary school. Them is your ups. All your fight and thing already, you get suspended. All your cliques. You're hoping that they fail mathematics, all kind of thing. I know what I'm talking about. This is opposite side. This is the hypotenuse, the adjacent side. All things in other school. Read the toxicity of your school. Very toxic. Or it have a nice vibe. Like my school, the school that I went in Form 5, I think it had the students had a really nice vibe. You know, we was real helping out each other. I love my school. The students was real nice. So it have a nice vibe. I know some schools is cliques and this one in this lessons and that one in that lessons and real pressure. Anyhow, so this stands for that opposite, hypotenuse, adjacent. And if you look at a right angle triangle, look at it. Look at this right angle triangle here. If you have, it really depends on what angle you're looking at. This is the right angle. If this is the angle in the question here that we're looking at, then guess who gets to be the opposite side? This is the opposite side. You understand what I'm saying? So if this is the name that we call this angle is theta. This means theta. And it's a fun nickname we give to angles in mathematics. Some Greek thing. This is called the opposite side to theta. Because theta over here and that opposite, it makes perfect sense. This is the hypotenuse and that will never change. Like some people, they never change. Hypotenuse. That's the hypotenuse, that's the height. He will never stop being the height. Excuse me. The hypotenuse, there are two ways to define it. Is the longest side on a right angle triangle, or is the side that's opposite to the right angle on a right angle triangle. So that just leaves this side. This side is called the adjoint. The adjoint. It's never called the adjoint. This is called the adjacent. The adjacent side. ADJ for short. So that's the adjacent, and the adjacent touches the angle. Now, the important thing to consider is that if the angle theta was not here, and I transport him and the angle in the question becomes theta over here, the hypotenuse never changes. The hypotenuse will remain the same. But all of a sudden, you gets to be the up and you get to be the adjacent. It's like you start off in Form 1 and that was your best friend, your adjacent, and your ups them was a crossover. And then, you know, them soldiers switch up on you. And by the time you reach into Form 5, them is your best friend now. Your best friend from Form 1 is your ups. Anybody best friend from Form 1 is the ups. So it really depends on where the angle is in. Don't mix up that. And so let's do an example. Let's say I said that this angle here is 42 degrees and this is 13 And alhamdulillah. Three possible situations. Real plenty situations, actually. It's more like I don't want to teach every possible situation. I'm going to teach you to understand the concept. So I'll just teach two situations that could happen. And in one of these situations, I would tell you what to do if it's on top or if it's below. I'll explain this now. Stay tuned. So one situation, right? One situation with this is that they could not give you the angle. They can be like, ha ha ha, you don't know what that angle is, but I'll give you two sides. I will tell you that this side is 11 and this side is 20. So this is one situation. Angle missing. So it's a special way to do this one. And then you have a next situation where let's use a next triangle, a next kind of triangle. They tell you the angle, you put back the 42 here. And lo and behold, a side missing. So that's our next situation. And I'll do two like this. I'll do two quick examples like this because I want to show you something. Let's put 10 here. Let's put this angle was 30 degrees now. And actually, don't put 10 there. Put X here. Let's put this angle was 30 degrees. And let's say this is 10 meters. So I'm going to show you two situations that could arise when you're doing it this way. So what I'm saying is, watch. You can have the angle missing. The angle is the unknown thing to find here. Or you can have a side missing. Why isn't it chat if you understand the two difference here, the two different situations that you have to use SOHCAHTOA. Sides missing. Why just mean yes, right? You understand? So we can either have the angles missing. Why is Kabi able to select things for one? See that part? That part sucks. So you can either have the angles missing or the side missing, an angle missing. But all the time, you have an angle and two sides. Angle, two sides. Angle, two sides involved. That is how you know you're using SOHCAHTOA. Because if it was three sides, what would I use? What would I use if it was three sides? Pythagoras theorem. So let's go ahead and solve all of these real fast. And watch the style. Watch the flow. Watch the pattern. So the first question to ask yourself every time you're using SOHCAHTOA, first question to ask yourself is what? What's involved? You need to start to look for the ups and the adjacents and the hypes. What is involved? This is the angle. This is an up involved here. You all agree? You seen it? We have an ups involved here and a hype. Then, when you're looking at what's involved, you need to study this. SOHCAHTOA. SOHCAHTOA. What we had again? The opposite and the hypotenuse. What do you think this O and H here stand for? Opposite and hypotenuse. And it's like three separate syllables. SOHCAHTOA. That means we stick into this first syllable here, which has the so and the S stands for sine. So it means you're going to use sine. So I start off with sine. Sine theta is opposite over hypotenuse. Lovely, lovely. And then I want to substitute sine theta. The ups is 11. The hypes is 20. And then, follow me now. Come follow me now. When you have one thing on one side of the equal sign and you bring it across, remember, really and truly, all I want is this theta here. What is this sign doing there? The sign is holding me back from being great. I need to get it across. When you bring something across the equal sign, you actually do the inverse of that thing. So I want the sine inverse, yes, it's on your calculator, of 11 over 20. So now, when I bring up my calculator, I'm going to look for sine inverse, put a fraction, put 11 over 20, press equal, and all will be well with the world. Make sure your calculator in degrees, it is not yet, it must have a little small d up there. And you get your 33.36. Most of the times they just want it a one decimal place. So you get your 33.4 degrees. not Celsius, just degrees. Rate out of 10 how much you understand now. You're learning things. So all the time, this question will come like this. There's nothing different that could come. You either use sine, tan, or cosine. But other than that, the flow will always be the same. You always have to bring it across, find the inverse, use your calculator for this last bit here. So you must use your calculator for this last bit here. Back in the days, you didn't have a calculator. You used to have something called tables. You used to be on the exam sheet and your exam table, and then bring out a big paper. So I had to go through the paper and find 11 over 20. What our ratio is an extra. It used to be a nightmare. Praise the Lord, we're in the calculator era. So sine inverse of 11 over 20, you use your calculator and you're good to go there. So how do we do these other two? Well, it starts off the same way. All the time in a SOHCAHTOA question, you ask yourself what is involved. So let's go and see what's involved. Hey, what's the question? What's involved? We have a ups again. You know, this is opposite to this angle because this is the right angle. We're assuming that's the right angle. And this is the hypotenuse. So once again, we're going to use sine. So we're going to use sine of 42. Well, let's write the whole thing. Sine of theta is equal to the opposite over the hypotenuse. And then we want to substitute. But this time, when we are substituting, lo and behold, 42 comes here because we know the angle. And with me, the 42 came here. Last time it was a theta. So this time, what's happening? 13 is the ups, x is missing. Now, I want to give you all a quick tip. If the thing that is missing is in the denominator, quick maths would say just to swap this with the sine of 42 and get your answer. Or you could go and figure out why that works. If you ain't understand transposition too good, sit down and study it and thing. But now, at this stage of the game, you might as well just take my word for it. So you're going to put 13 over sine 42 and press equal, and we get 19.4, 19.42, 19.4 units, not degrees. Why is this one not degrees? Because we're finding a side, we're not finding an angle. This is a side. And always check to see if your thing makes sense. Yeah, this really feel like it could be 33 degrees. Yeah, this really feel like it could be 19.4. If you get 200, you're going to write in the exam and stand by the answer. See, some always be standing by all your X and all your X's be doing nonsense. Don't stand by X if your X stating nonsense, right? So if it's 19.4, that's looking good. That's looking good. The hypotenuse had to be the longest side. But it can be 200 if this is 13, right? So 19.4 looks good. Let's try this one. This case, however, you all see that we have the adjacent involved. It's not the opposite, it's the adjacent. And over here we have the hypotenuse. So in this case, excuse me, this is what we'll use. Adjacent and hypotenuse, you use C. C stands for cosine. So you say cosine of theta is equal to the adjacent over the hypotenuse. We substitute cos of 30. Notice how we get an angle substitute is x over 10. In this case, notice the x is on top. That's what I wanted to show you. In this case, the x was below. This case, your x on top. So if the x on top, bring across the 10, you'll get x is equal to 10 by cos 30. Multiply both sides by 10. 10 cos 30 is equal to x, and I just swap it one time. Once again, you go straight into your calculator and write that exactly. 10 cos 30. 10 cos 30 equals 8.66 units. Three significant figures. Or meters, they actually give us the units this time. So that's a quick crash course in basic trigonometry that could come very easily in your question 3. So I hope you all feel a little solid about that. If you need more information on it, just look it up. Kerwin, Springer, SOHCAHTOA, Kerwin, Springer, Pythagoras theorem. So let's jump back into the question. We now on the second page. The diagram below shows an equilateral triangle FGH, which base is 13 and its height is h. Calculate the value of h. All right, they give us a lot of information in this triangle. I don't know if you realize it, but we got information. What are the piece of information that we got here? Equilateral triangle. An equilateral triangle would mean that all of the angles are 60 degrees. So it means this is actually 60 degrees. This is 60 degrees. We could consider one piece of this triangle. This wouldn't be 13 anymore. It will be what? 6.5, half of 13. After, let's call this the center O. This is 60 degrees. Which one are we going to use? Do we use a Pythagoras theorem or do we use SOHCAHTOA? Pythagoras theorem or SOHCAHTOA? What are you feeling? We know this side is 6.5. We have another side here which we are trying to find, that's H. And we have an angle involved. If you have two sides and an angle, you use SOHCAHTOA. And the first thing you ask yourself is which one? Which one in SOHCAHTOA will you use? So how do you figure out that? Which sides are involved? This side is not the hypotenuse, don't mind it called H. The hypotenuse is not involved in this. The hypotenuse, they mind in your own business. So what is involved is the opposite and the adjacent. Definitely we are going to use tan of the angle is equal to the opposite over the adjacent, SOHCAHTOA, the TOA part. And then we will write in the substitution. Tan of 60 degrees is equal to the opposite, which you're trying to find, H over 6.5. And if the missing thing is on top, you just multiply. You see the shortcuts is coming handy. Good things as we given all in. Good things. Lock in all you, lock in. So 6.5 times tan of 60 is 11. How do you wait? How do you wait? They never specify. So 11.3 to 3 significant figures, 3 centimeters to 3 significant figures is your answer. What do you feel about that? All of a sudden, it looking good, looking like you might be getting all the trigonometry questions in the exam, right? It's not that bad at all, not that bad at all. So let's go into some transformation now. The diagram below shows 3 triangles, P, Q, and R. Triangles Q and R are images of triangle P, and after it undergoes a double transformation. Now, I need you all to know that I've been doing a lot of transformation on my channel recently and on TikTok. So I expect most of you all here would have probably seen it. So I'm just going to really read through this part. So hang on to your hats. It's going to be a little fast. Transformation. In this part of the paper, you would have to deal with 4 types of transformation. And you're more dealing with it from a geometrical standpoint. Geometrical and graphical standpoint. So graph, paper, and thing involved. So that's how you're looking at it. You're not dealing with it from a matrix standpoint. That's later on. Right? Not yet. Right? When we start matrices. So the 4 types, well, you know them already. The 4 types of transformations, see them in the chat. All of them are called transformations. 4 types of transformations are reflection, well done, Shemika. Translation. And people say, so what about glide? What about glide? Every time I'm teaching this, it must have somebody in the chat. So what about the glides? What about slides? Like translation. And rotation. So this is glide as well, right? Glide translation, same thing. So reflection, translation, glide in Latin. And all of them, you need to know a bunch of things. Firstly, you need to know how to do one, how to do them. You also need to know how to identify them. And you need to know how to, this is important, describe them. So you need to know how to do, identify, describe. By do, I mean draw and thing, right? So some words that happen. If you start off with this, and then you produce this. This is the starters, like where you start off with. But just in maths, you can't call it these starters. So what is call it? What's the term we call it? We actually call this the object. And this one, we call it the image. And just to denote that this P is not the same as that P, we give him a little dashes on the top like this. So object to image, P prime, Q prime, R prime. Felt? Everybody understand? Object to image. And in this case, they're looking like a reflection for sure. So let's go see how we describe them. So a reflection, to describe a reflection, all you need to describe a reflection. Hey, English people, English class now finish the 12-hour crash course in the student. Tell Miss I say hello. Tell Miss I say hello. Hi, Miss. I'd sneak in earlier, and I think I'd sneak in and just sneak back. I think. So reflection is to describe the reflection, you just need to know one thing. What do you need to know? What do you need to know? Reflection is easy to describe. All you need to know is the equation of the line of reflection, or the line of symmetry for some people, the line that flips the image to the object. That's all you need to know when you describe the, some of you all call it the mirror line, all kind of lovely names you all have for him. You just need to know that equation. You just need to know the equation of that line. And you're done. You describe your reflection. But you must understand what equation of a line mean and all kind of thing too. That could get a little ticklish. Anyhow, so translation and glide. What do we need to know for translation and glide? Hi, Jada. Tell Miss say hello, Miss Rian. Hi, Miss Rian. That's a crash course in the student. I've now finished. 12 hours of English. Translation or glide. What do we need to know? We need to know how much horizontal and how much vertical movement we have. And that is best described as a column vector like this, x, y. So how much do you move across? How much do you move up or down? Enlargement, what do you need to know? Two things for enlargement. What do you need to know? You need to know your center of enlargement or reduction. And you need to know your scale factor. Well done. And when you're describing it, you need to think of these things when you're describing it. This is extremely popular these days, so please pay attention. Look back at the last 5 past papers and those see it nearly every single time. And they're making you describe it in big. So rotation, you actually need to know 3 things for rotation most of the times. What are the 3 things that you need to know for rotation? Of course, you need to know your center of rotation. You need to know the angle of rotation. Are we rotating 90 degrees to 70 degrees? Is that 180 degrees? Is that full 360 degrees? I don't think I ever see that. And then we need to know the direction. Sometimes we don't need to know this. Like if it's 180 or 360, we would need to know the direction. But this direction doesn't mean like left or right. This means anti-clockwise or clockwise. CW stands for clockwise. ACW stands for anti-clockwise. So all of these things must be touched on when you are describing the transformation or doing the transformation, finding stuff out about the transformation. All right, so let's just do the questions, and as we reach up to them, I'll show you different tricks. The diagram below shows 3 triangles, P, Q, and R. Triangles Q and R are images of triangle P after it undergoes a double transformation. Triangle Q and R are images of triangle P. So use the boss, use the object. These are images. That means the imitations. After it undergoes a double transformation. Okay, fine. Describe fully the single transformation that maps P onto triangle R. How are we going to get P to R earlier? How are we taking P and sending it to R? We got to put a rate limit on these things because there's a why you type in 200 times in the chat for Yeah, how we sending Peter R earlier? Now translation, that the only way you can reflect that didn't look like in flip. You can rotate it in feeling rotation vibes, it didn't enlarge at all. So the only thing you can do is slide them up. A gliders, a translation. So all we need to do is find a point on MD, boom. Find the next point, the next corresponding point, and see what it takes to get there. Well, it looked like you're going to take a 2 across. We in the line there, we in line, yeah, we in line. 2 across, and then, so that's 2 here, and then 1, 2, 3, 4 up, 4 up. So, describe fully a translation. You have to say what it is, right? A translation or glide or slide. A translation, 4 units. What was 3 or 4? 2 units, yikes. 2 units to the right and 4 units upward, which can be described as that is 2, 4. You can describe it using like that. So that's one. Part 2, how are we going to get R into triangle Q? How are we taking R and reaching Q now? R to Q is a, hi Megan, R to Q is definitely looking, you see that reflection vibe there, you see them kind of turn around so, right? So the thing is a reflection, but to describe a reflection fully, you must know the line of reflection. So let me do and talk some things here, boy. What's the thing I use, boy? What is the graph? Oh, decimals. We're going to talk about some equation of lines, because some of you really understand equation of lines. All you're bluffing right now. Some of you bluffing. Well, look at this axis. It's kind of beautiful. It's a beautiful place to be in coordinate plane, Cartesian plane. See, namely, if I draw a line like this earlier, like this, straight up on that 40, everywhere on this line, like if I do this point there, if I draw a line like that in CXC, they will laugh at you. I just draw that so you can see. As a matter of fact, that line irritated. I just draw this line thicker using a normal map or something. So, boom, right? So if you do that, this point is the point 4, 2. Are you agree? 4 on the x, 2 on the y. This point is the point 4, 4. 4 on the x, 4 on the y. Well, you know how to do the points and thing, right? I mean, I can't be teaching points right now, and I ain't gonna look good. So I know my students have no points. This point here is the point 4 on the x and 6 on the y. It don't matter anywhere along this line, the x point is always, the x value is always going to be 4. So we might as well just call our line x is equal to 4. Oh gosh, we just understand it. We understand x is equal to 4. And the pause supposed to be raising, my pause raising, and the pause raising. The line x equal to 4 is a straight line that passes through x equal to 4. And it don't matter what x equal to, if x is equal to 1, it can pass through 1, a straight line passing through 1. You understand? These lines must show up in CXC. A line like this must show up. Y is equal to 3 is a horizontal line because now it had a pass through the y is equal to 3. So these are some special types of lines. If you know your coordinate geometry, normally you get the line y is equal to mx plus c, right? Normally you get these types of line. Y is equal to mx plus c. Look at a sample of the line here. And the m and the c take on different values. Like I can make c go up. C is the y-intercept. We'll talk about that when you're doing coordinate geometry a little more. C is going through 4. You seen it, class? And the gradient of this graph is 1. So this is basically the line y is equal to 1x plus 4. This is the styles of lines we are accustomed to, but there are special types of lines that could be either vertical or horizontal, depending on whether you say x is equal to 4 or y is equal to whatever. So please learn the difference, understand those lines. It could show up in this question, right? So if you look at this, I believe everyone can use some reasoning and realize that this is being reflected across this line. The way of figuring it out is to connect 2 points and bisect the line, and the perpendicular bisector is the mirror line, the line of reflection. Connect 2 corresponding points, bisect it, and that will be the mirror line. And we can see that this line has to pass through 1. So it's a vertical line passing through x is equal to 1. Therefore, this is the line x is equal to 1. So if I want to fully describe this, I must say that it is a reflection. And then I must say the equation of the line is being reflected. In the line, x is equal to 1. Everybody understand? So you get 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for that. And you collect all your marks. What do you think about this question? This came in January this year. Easy construction, easy trigs, and easy transformation. This is the best case scenario. This is the best that could ever happen. Easy transformation, easy trigs, and easy construction. You're getting full marks. Let me check out that next question. Using a ruler and a pencil, construct a triangle ABC. AB is 5.5, angle ABC is 90, and BAC is 60. So let's go and do that on my little construction thing there and hope that the thing wasn't slowing me down. Where's the name of this site that I just pull up before class start, boy? Construction tools. All of a sudden, my things had to stick, boy, construction tools. Hope it's not you causing that thing. Yeah, so all I watch this day, we're gonna hit them on next one. We're gonna say AB. Okay, what's the first thing you always do in a construction question? I didn't say that yet. So there you in the exam here. What's the first thing you must always do when you're in a construction question? First thing, yeah, construction equipment there and thing. What's the first thing? First thing to always do in a construction question. Draw the baseline, draw AB. No. That's not the first thing to do. That's not the first thing to do. That's not the first thing to do. That's the first thing to do. Draft it out, Eli. Well done. Draw a sketch. Draft it out. Trust me on that one. So watch how I go and draw the sketch, right? Watch how my mind thinking here. Watch what I'm thinking. I'm going to draw the sketch there. So AB is 5.5. So I'm looking at AB something. So 5.5. ABC is 90. So C gonna be up there then. 90 like that. And BAC is 60. So this is like 60 this way. 60. So what you telling me? And then you're kind of making a mental note. We're gonna draw the ABs. We're gonna construct a 90 and draw a line going up. So construct a 60, draw a line going so where the two intersect. That is in there. That is in there. And now you start. You're ready. And how long that take? That take like about 20 seconds. And the reason why you're doing that is you're kind of visualizing everything. You check and see. Using the diagram, measure, you have to measure, and then going on to the next thing. Because sometimes they can make you extend the next. You know, it's the worst case scenario in an exam. You start to draw your thing here, and lo and behold, your diagram finishing in the question. This is real happen to students now. Because you start your baseline too high. And you're sweating in the air, feeling kind of lame. Anyhow, so you whip out your ruler and you hit them the 5.5s. 5.5s, not a problem. We just go in another step right here. Now, really and truly, you're supposed to show a little kind of construction for this. If you know, those of you who know your technical drawing. So you're kind of showing them that you constructed that 5.5. So what I do is just ratchet and do a little line like this, right, on the 5.5 day. And because remember, this is construction lines. This will extend a little bit. So that is your 5.5. Watch my construction video, you'll see exactly what I'm talking about. So this is my 5.5, and my baseline went a little longer. It actually supposed to go longer on both sides. All right. Next up is you want to construct a 90. So you're going to set him up here because we know the 90 was on this side because we do the sketch. We's not all lame people. All right. And we circle this around. You all know how to construct the 90. You could always watch to see. On my other video there. You come below trying to make it draw. Oh yeah, they touch up here to make it draw. Thing, bang. Keep going, brother, keep going. Then you take back the same compass and you come here now. And you do so. Yeah, then lock it, lock it. And you make a next cut there, bang. Then you come here, so. This is the fancy way to make the 90. Then you come here, so. Why not locking this thing? Why trying to end up in problems? And bang. If that was too much for you, and you're confused, like what in the world? You can check my video on it. It's actually simple. What we did is we made a 60 degrees. We make a next 60 on top of it. So that's actually 120, and we bisected between the two of them. There's another way to do it by making the perpendicular bisector, but that's technical drawing students only know that method kind of frowned upon, like the little boy method. All right, so then we line up the ruler, like this, so hoping that everything is right and you know what you're doing. And you just draw your line. All of these is construction lines on there. Move your ruler. That was the 90. We also need to hit them at 60 on this side. So come back here, my boy. Lock in. Come in here and you're going to organize that 60 for me there, right? So you're going to go down. Come back up. Remember to organize that 60. You keep the arc like that. It needs to be the same size. You bring him up. You bring him up. Hey, lock back there. You bring him across here. So on that point, here's the next little arc. Bang, bang, you could come out. So you see, in 60 there. Now I just need to take my ruler. You can't use a protractor because they want you to use a ruler and a compass. You can always verify it with your protractor and make sure the thing correct. So you're looking kind of silly out here if the thing wrong, right? Look like I needed to extend that 90 some more, boy. Look like I needed to extend that 90 some more. This look like a question I could end up inside the question for real. Oh yes, I feel like I do a day walk. Then yeah, do so. Now some of y'all must be wondering why this man drawing this thing looking so scrappy and them lines all over the place and crossing each other and all kind of thing. That's actually what you're supposed to do. Believe it or not, that's what you're supposed to do. So pretend that line was drawn straight with the other line. So then what you need to come and do now is darken up everything and finish strong. So you will make the triangle, though do it in a different color. So be back. Yeah, just do it in the same color, but it will be like the 2B pencil now. With the construction lines, you're probably using your 2H pencils. You see? Then we teach you. This ruler kind of hard to use too. Gosh. Could I make it smaller? No, I can't. Actually, let me draw the diagonal line first. All you hear now screaming, Zio screaming in the background. Zio is my youngest son. Already? Are you just watching the magic? I wonder if anybody drawing it with me? I'm struggling to move this ruler backward and forward, but it's not as easy as it looks. And then, what do you think about the track? I can't even go and watch it now. Until they say Drake responded to the next track. So what you're saying is exam season where distractions going to be dropping. And there we are. Oh gosh, that was tiresome. And then we're going to label him up A, B, C. Yeah. So you get to be A. Why that compass like to come out? So every time I change the color, the compass coming out. You get to be A, you get to be B, and you get to be C. And you also need to dimension the given thing. So I'll dimension this as 90. I'll dimension this as 60. Hey, it's this program that I was doing it earlier. It start back skipping again. And I will dimension this as they gave us this. This was 5.5 or something like that. It's like this program was causing the sticking. This was 5.5. Or is this program that causing the sticking? Whoever use that program again. Goodbye. Never to be seen again. I hope I don't need to restart. All right, it looked like a escape. So we just drew that, right? So all you understand? If you need more information on this, I will skip the sketch. I'll skip the construction questions now. I have a really nice video set up with me actually using the devices and giving you relevant tips for it. So please watch that if you need to, if you know you're not good in that. Go and watch that construction video. Using the diagram construct, measure the parts. So you're supposed to take a ruler and measure AC and see what it was. The diagram below shows the floor plan of a hallway in a theater. All measures shown below are recorded in meters. And why this looking like? This looking like a algebra mixed with geometry. Like it could have come in a number 2. Given the width W of the hallway is 12, so this new friend, so this is 12, find the value of X. What in the world? Yeah, we could. How are we going to do that? If this W here is 12, what is X? Well, it have X here and it have 2X there. W is 12. So therefore it means, therefore what that means? That means 3X is equal to 12 from the diagram. You can see what I'm saying? Or I could say it separately. I could say the X there plus the 2X. Because remember, I have an X over here because this is X. So you have this X plus you have 2 more X there. So X plus 2X is equal to 12. So 3X is equal to 12. What that means? That means X is equal to 12 divided by 3. X is equal to 4 meters. 4 meters. So, and the length of the hallway, well, you have a little something to do here because this is 5. This over here is 4. So we kind of have to figure out this side. We know this is a right angle. So examining that triangle, we're going to use Pythagoras theorem, and it's a Pythagorean triple that you should know about. If you work it out, this side will just be 3, but we could show it. Let me just show you why it will happen, right? So this is A, this is B, this is C. By Pythagoras theorem, C squared is equal to A squared plus B squared. We did this just now in detail. So 5 squared is equal to the A, which we're trying to find, right? Squared plus B, which is 4 squared. So this is 5 squared is 25. The 4 squared is 16. When I bring it across, I'll get A squared. So I get A squared is 25 minus 16 is 9, and A would be the square root of 9, which is 3. So this is what we call a 3, 4, 5 triangle. A 3, 4, 5 triangle. Right? So we know that this piece here is 3. Now, since we know that this piece is 3, this piece is 10, X is actually 4. Therefore, L is equal to 3 plus 10 plus 4 is equal to 17. So we find L. So they make we take a L and a W. Determine the area of the hallway. So to get the area of the hallway, you need to find the area of these 2 rectangles. You can split it as a compound shape. This is a measurement question mixed with a trigonometry question mixed with an algebra question. They're real mixing and matching here. So we need to find the length of the area, sorry, of all these 3 shapes. So let's go ahead and do that. I'm erasing L. We already found L. The area of these 3 shapes, the triangle will be base by height divided by 2. So this is one of the rare situations where you get to use this base by height divided by 2. Normally, you have to use a little more complex stuff to find the area of a triangle. Base is actually 3, height is actually 4. So this is 3 by 4 divided by 2, which is 6, right? 6 square meters. 6 square meters. So the area of 1, and then the area of 2 is going to just be this length by this width. So length of 2 times width of 2. So that'll just be 10 by 4, which is 40 meters squared. Hold up. 40 for real, right? 10 by 4. And why you use again? 3 by 4. 6. Okay, fine, fine. And the area of 3 is going to be length of the third length by the third width. They're calling this that, but that's W. W was what we get for W again. What we get for W earlier? They told us that 12. They told us that 12. 12 by another 4. 12 by 4 is 48. 48 square meters. So we add all together. And we will get our answer, our total area. Where am I in this paper, boy? Halfway. When we add all together, what we get? 94 square meters. So the total area is 40 plus 48 plus 6 is equal to 94 meters squared. Just like that, we knock off our next question. So I think this is an oldish style of question here, but we can still encounter this very easily in our exam. Covered a lot. I'm going to skip this construction part. The solution is here. Those of you all in class, I'll send the solution. Class people. Here it is. So we have using a pencil ruler, what's the construction would look like this. Note, we had to actually construct a 120, then use our compass and make a dash at 5.5 for this. This is what they will be looking for in the exam, X, Y, Z. Shout out to Miss Nalini. This is most likely her handiwork here. So we had to construct a 120, make that go up there. Beautiful work here. All right, and the next part of the question was, what is the length of side XZ? We'd have to measure it. So this part is done. Construct the point W such that WXYZ forms a parallelogram. So now we need to go ahead and take this and make this into a parallelogram. So when we measured it, this was the length. But now when we take it and make it into a parallelogram, we get this XYZW. So this used to be the classics that used to come. This used to be the kind of quality things they used to be bringing back in the days. And it can still come, but construction at this depth has been kind of like a unicorn in the last 5 years. So it still is there. The threat is still there that something like this could come, so make sure you know how to do it. Then we have a right angle triangle, and we need to find the value of C. What are we going to use? Are we going to use SOHCAHTOA, or are we going to use Pythagoras theorem? What are we going to use, class? Come true. What are we going to use, class? SOHCAHTOA or Pythagoras theorem? Some people saying SOHCAHTOA. How are we using SOHCAHTOA? Remember, SOHCAHTOA is if you have two sides and an angle involved. Well, I know two sides and I have the angle. I guess I could use any one, yes. Well, that's if I want to. I don't know the angle. That's if I'm trying to find the angle, but I'm trying to find C. I'm trying to find C. So I have two sides and I'm trying to find C. So what's involved then? 3 sides. If 3 sides are involved, it can be SOHCAHTOA. So I have to use PT. And I'll say by PT, C squared is equal to A squared plus B squared. I'll put A here I put B there. And I just go through strong. 5 squared plus 8 squared is equal to C squared. So this is 25 plus 64 is 89. C squared is that. So C is equal to the square root of 89, which is, good night, everybody, which is equal to 9.4, 9.43, 9.43 centimeters to 3 significant figures is a good place to. They wanted it to 3 significant figures, actually. So usually it's 3 significant figures, understood. And now you need to determine the value of theta. So now that we have theta in the question, now we will use SOHCAHTOA. And which one will come out? So, ka or toa? Sine, cosine, or tangent? Which one will surface when we examine and see what is involved? Well, this is the angle. We just found out this side, but let's avoid using this side since this was a derived something. So we really have the opposite and the adjacent. So definitely the best thing to pull out is tangent. So you're going to be like the tan of theta is the opposite over the adjacent. So the tan of this angle is 5 over 8. We're trying to find the angle. So you bring across and you get the inverse of 5/8. The inverse of 5/8 is tan inverse of 5 over 8. Put it in your calculator. Make sure you're getting the same thing everybody's getting. You're getting 32, almost the exact, because it's 32.005. So this is 32.0 degrees. The reason I put 0.0 is because they wanted it to 1 decimal place. And that is you there. Max collect. What y'all think, people? So we have the diagram below shows figure ABC. State the coordinates and do an enlargement. Scale factor 2. Can we fit an enlargement there, boy? So what I'm going to do, I'm going to speed through and do a couple enlargements and bring down the curtain. I see like some. I'm going to speed through the rest. I already did a bunch of transformation. That's why last night we spent a lot of time on algebra. We actually went 2 hours last night. These lives only supposed to take an hour to an hour and a half. Is already an hour and a half. But we had a rocky start again. So what I'm going to do is show you some of the solutions to the transformation. But we would have already covered the the 2 other areas that I wanted to cover. So there's transformation, which I didn't really do a lot of tonight, but I did a lot of that this month. And there's a lot of it on the channel. You can go and look it up in the recent live videos and the recent posted videos on TikTok and them kind of thing. So transformations lock. The next 2 things I covered, the construction. We did a couple of that tonight. We did some of the basic ideas. We did some of the more advanced ideas. We did a full construction. And of course, you can bolster this with watching the recordings on construction. The next topic that comes in this question 3 is really basic trigonometry. And I went through that. I went through Pythagoras theorem and I went through SOHCAHTOA and I looked at different situations that can come and we look at exam questions. So what I want to do is just skim through some and show you some of the ideas in transformation to look out for. So use a ruler and a pencil to do this. Then there's this figure and we needed to state the coordinates of point B, which is actually 5, -6. But more importantly, let's look at the scale factor for the enlargement of AB and then the reflection of ABC in the y-axis. So let's go and see what happens there. Let's investigate. So this was the construction again, another construction question where we had to draw 6. We draw the 30 degrees, extend it, and then we use our compass to cut it at 9 centimeters. And then we connected everything back. I notice how there's light construction lines and solid lines for the final diagram and the dimensions. This is the line AB in the enlargement. What was it about the origin? From the origin, scale factor 2. Yes. So what you're supposed to do, Take your pencil, make a point there, connect it to A and extend. You gotta be real careful when you're doing this. Straight. Keep it straight. And extend. And you want this distance to double. And that's where your point is going to be. They want to see the guidelines here. So make sure and put in those guidelines. And you get that point and that point. Or they just know I just need to farm and a little type. Oh, they were really going on with you, boy. And some kind of something about yourself now, boy. What's really happening to you, boy? Take a 24 hours day now, the opposite. Yeah, take a relax. Gosh, man. You studying with little maths here and you coming in out of time in, so boy. When you write that, when you come on YouTube, right, and maths live, whole Caribbean and thing, and you write something like that, I wonder how you feel, boy. Like I write something naughty. I is a naughty man. I write something. Lord, watch out, all of them there they read that. How childish can you be? Jeez, man, you lay down the whole country there. I hope you're not from Trinidad. Come on, man. Have some kind of something about yourself. Better you write them things up and stick it on your wall and inside and thing. People is become anonymous online and do things they will never do in real. They will never do it in real. But you know, you're online and you're anonymous now. I always wanted to say this. I'm going to write this. Gosh, jeez, shameful. That is like if you really stop and think, I know you're still on this stream and you're watching me. If you really stop and think about it, you're in a heights of lameness there, some heights. Anyhow, yeah, so we stated the coordinates and we needed to draw A, B, C, D in a reflection in the y-axis. So what you needed to do, I guess she wanted my attention. Well, you get my attention there now, bro. You get my attention there. But oh gosh, all you had to say was, sir, I need a little attention. Please. You needed to write all them thing and shame the nation and thing. So the same distance A is from the line of reflection is the same distance A double prime would be. You understand? So I think what do you feel? I feel like we reach where we're going there. There's one other thing that you could learn for this topic that I kind of left out. I should include it here. Is shapes and solids. Maybe I should do one short form video with all the different shapes in CXC, all the different solids and the facts and stuff that you need to learn. And that also includes something that I taught last night with the internal angles. I remember that with the shapes, and I taught how to get the internal and external angles. So you need to understand what is vertices, edges, and faces. I mean, they primary school thing, but yeah. You need to understand that. So I think we're good. We're going to overfight it up tonight. We're going to over push tonight. Tomorrow night is measurements. No, tomorrow night is relations and functions. You got a little graph something, but basic stuff. So f of x, g of x, g f of x, f inverse of x, them kind of thing we could be learning, relation diagrams, we could be studying that. This could be a short session tomorrow, that is Monday. And then after that, we're going to learn, the day after that, we're going to learn statistics. That's Tuesday. So this is Monday, this is Tuesday. And after that, measurement on Wednesday. Then on Friday, we're going to learn the series and no, sorry, I missed a day. I don't know what days are the week. Thursday series and sequences. So Monday, Tuesday, Wednesday, Thursday, and on Friday we coming back. That I wanted to relations and functions and graphs in a big way. That will be completing this way. So by Saturday, I will just knock off our next thing, geometry and trigonometry. Vectors and matrices, I might do it on the same Saturday too. So I might knock off 2 on Saturday actually. And I will actually have a long 12-hour crash course to do on Sunday. That one is a paid thing. Those of y'all, if you have the cash and you want a little extra push, that's the number to WhatsApp. You can join us. Join the whole team. Join the class at the student hub. You can still jump in. It's 300 TTD. Same as 7,000 JMD. And yeah, we're gonna be studying. I think it's from like 11 a.m. to 11 p.m. If not 10 a.m. to 10 p.m. thereabouts. We'll be grinding through the entire of mathematics again. Because my class would have done it whole year. Then we did a crash course in April. We'd have done some crash courses in December. So all you're gonna get a little extra final push into the exam. So for now, let's just read some comments. So since you're not joining the rap, please do a little prayer for us. You can see. Well, wait till Friday. This is the last push. Yeah, the last push. You're welcome, Shahida. Bless up. During the week as well. So I'm doing this 7 p.m. It depends on how high my energy level is. I feel you can touch a little physics too. I feel you can bring on bio teacher too. Physics, bio. You could sneak in a little chem. No, chem coming up. Chem already. The chem exam happening. When is chem? I just upload a whole chapter 1 in chem D. So they could go and vibes that. We can do this. Well done, Justine. Well, Justine, you bright like bulb. So you definitely doing this. Still link at geometry set. I don't have anything. Add maths here. Add maths could come through. Touch physics, I need that. Yeah, we can do a little. We might be able to catch all the topics in physics, but we can do things like nuclear physics. We can do things. We can do things. We can do things. Wait, Noella, bless up, bless up. If I know woodwork, nah. Any good channels for history? Yeah, let's check the student up for history. I don't think we have a 12-hour in history though. Physics and chem coming. Right now the AC beating down on my back feeling cold. Yeah, so I do some free sessions on YouTube, but this one is the paid session. This will be real good. It'll be a real nice. It'll be before the exam. Everybody energy is be high. Nuclear physics is easy. So what in physics are electricity? Let me do some electricity in physics sometime. Calculator tips. Just search Kerwin Springer calculator tips online. Make sure you have energy. Them technical drawing exams will be long. Very long. So make sure you have some good energy. Bless up in the exam, Varun. I know you're going to handle it really nice. Make sure everything, you have all the equipment and things set. So not much I can tell you now to change the difference. Just make sure everything's set, right? Let's go, fan. Right now, better use a Lasco fan than an AC. So don't study them, do nuclear physics. Just sign up for the physics and chem. Anybody else sign up for any crash course? How much is 300 TT in Guyanese? You have real Guyanese students, and what most of them is do is pull up Google and search for themselves, bro. It's about 9,300 or so, 9,270 Guyanese. 9267.30 to be exact. So yeah, we have the second most among the students in the student have come from Guyana. And them Guyanese students will be doing real subject. 10, 13 and all kind of thing. So let me get easy then. Well, see, another stick in the wall. No, you do everything in pencil. One is a light pencil and one is a darker pencil. For IT, use make IT simple. TT endorsed. I'm a brethren. Yeah, respect. I just wait for the live to reach like under 500 and then I'm busting out. But like, all they don't want to take it under 500, people still here. So do I give away? And really, I'm not to give away again. I give away the 2 calculators already. Excuse me. Y'all call Gordon Technology. Those of y'all who needed to get the calculator. I tell you, that's me there, you know. That's me there. Yeah, we are IT. We are everything in the student. But they make the calls. Love and blessings. Ishan. Big up Haiti. Telling me to again. End stream.